Okay, our objective today is to graph radical functions, and we're going to do cube root functions too. We started this yesterday, and we're going to continue on today. We're going to reinforce what we learned yesterday. All right, so this is what we did yesterday, and I'm going to do it pretty quick over again. Some people were absent. This is the parent function. Travis, is it too far? Can you see it okay?
Yeah, I can see it.
All right. So we're going to first start off by graphing y equals the square root of x. What numbers, what x values can you, in your head, without a calculator, take the square root of?
0.
0, 1, 4, 9, and 9. Awesome. What do you get when you take the square roots of these?
1, 2, and 3.
Okay, so this is where we're starting off. This is called our parent function. When you graph these, what does it look like? Here are your points, 0, 0, 1, 1, 4, 2, 9, 3, and then there's more. And there's actually a lot of them in between these numbers, but why don't we list them here?
It's not perfect.
Because they're not perfect squares. Excellent. So these are the ones that we're going to do in our head. Now, do you remember what happened? We looked at what the effect was when we had numbers after the radical. What did these numbers do? You added or subtracted these
Up or
to
down?
the y value. Yes, it moved it up or down. It shifted your graph up or down, so it's going to affect the y value. So if you had a number like plus 2, what did you do? You took your parent function and you added 2 to your y values. If it said minus 3, you took your parent function and you subtracted 3 to the y value. So what it did was it shifted your y value. Okay, remember that?
Yep.
Then we did this yesterday. If you saw something under the radical, it moved it the opposite, left or right, horizontally. So we took our parent function, and when it said x minus 3, I know it says minus 3, you're going to add 3 to your x values. What x values am I talking about? The 0, 0, 1, 1, 4, 2, 9, 3. So this one says plus 2, we're going to subtract 2 from the x values. So what it's doing is it's shifting your graph left or right. So the square root of x minus 3 is going to shift your graph 3 units to the right, and the x plus 2 is going to shift it 2 units to the left. That's what we did yesterday. Then we did this. What happens when there's a number in front of the radical? You will multiply. This is going to stretch your graph vertically. You're going to multiply the y value by whatever that number is. So then we put it all together. What happens when you have all 3 combinations? What are you going to do first? You're going to take your parent function, which is 0, 0, 1, 1, 4, 2, 9, 3. This is the parent. This is the problem 3 on the notes. We did this yesterday. So you're going to always start underneath the radical. You do the opposite of this to the x value. So the first thing you're going to do is take your x values and subtract 2. This is the only operation that you do the opposite of. So x, we're going to take our x values and we're going to subtract 2. What x values am I talking about? These ones right here. So subtract 2, subtract 2, subtract 2, subtract 2. Keep your y values the same. Then you move on to this number right here, this 3. These 2 numbers affect your y value. You're going to take your y's and you're going to multiply them by 3. So all of these multiplied by 3 gives us 2 times 3 is 6, 3 times 3 is 9, 1 times 3 is 3, and 0 times 3 is 0. Keeping our x values the same. And then the last thing, you're going to subtract 4 from these y values. So you're keeping like a running. Do you get this? Subtract 4. So 0 minus 4, 3 minus 4, 6 minus 4, and 9 minus 4 is 5. Keeping these x values the same. Then when you graph this, over 2, down 4, over 1, down 1, over 2, up 2, and over 2, 3, 4, 5, 6, 7, 1, 2, 3, and that's what you had. Okay, next page. I hope you did these, but we're gonna run through them very fast. Okay, starting off by doing what? What are you gonna put in your first column?
X was 3.
What's your first column?
Parent.
Your parent. What are they? And that's all you really have to do. All right, now we have A, B, C. This is our A operation, our first one. Do we have 3 operations that we have to do on this one? No, so we don't even need this column right here. So what's our first thing gonna be? What are we gonna do with our X value?
X was 3.
We're gonna add 3. Can you add 3 really quick to these? And keep your Y values the same. And then what are you gonna do? You're gonna take your Y value and add 2 to them. What Y values am I talking about? These ones. So add 2, add 2, add 2, add 2. And now we're going to graph this. Over 3 up 2. Over 4 up 3. And over 7. 3, 4, 5, 6, 7, 1, 2, 3, 4. And I think 12, 7, 8,
All the thing.
it's right. Okay, now, how do we check this on our graph to see? You're going to go to New Document. We're not saving anything. Add a graph. And we're going to type in square root of x minus 3. Bump yourself out of that radical and then plus 2. And then hit enter. Does that look like our graph? Does that look like what we just did? Now let's verify our table. Hit Control T. And let's look at our points. What was our first point? These are errors because you can't take the square root of a negative number. So is our first point we got is 3, 2, we're there. 4, 3, we're there. And then let's arrow down. Let's make sure we got 7, 4, we're there. And 12, 5, we're there. So guess what? I could have showed you how to do this on a calculator, but we used our brain. So our brains are getting smarter and smarter. But what did the calculator do? It just kind of verified that we were on the right track. Okay, so can I hear number 2? What did you start off with?
Parent, XY.
Parent, XY, 00114293.
X plus 1.
Good job, you start here. You're gonna take your X value and you're gonna add 1. D'Angelo, can you tell me what you got when you added 1?
1, 2, 5, 6.
Okay, then what?
Then you kept the Y's the same.
Kept the Y's the same,
And
yep.
then you did 2 times Y.
2 times Y, and what'd you get?
1, 2, 5, 10, 0, 2.
Wait, the Y value times 2?
No, I'm saying for that. I kept the X's the same.
Oh, okay,
And then-
1, 2, 5, 10, yep, thank you.
And then 0, 2, 4, 6.
And then what?
And then Y plus 3.
And then what'd you get?
1, 2, 5, 10 again. And then 3, 5, 7, 9.
Okay, can you, Jack, type that in? Type that equation in for me. And I'm gonna graph this, 1, 3, 2, 5, 5, 7. And then 5, 6, 7, 8, 9, 10, 11, 12, 5, 6, 7. Okay, and Jack typed it in for me. So we can save time. Control T. Let's look at our graph. Are our numbers right? 1, 3, bingo. 2, 5, good. 5, 7, good. And 10, 9, good. Excellent. Next one.
Parent.
What's the parent?
0, 1, 4, 9. And Y is 0, 1, 2, 3.
Good job. This is the parent. Then what are you gonna do?
Well, okay, so I see the +4 isn't inside the thing, so I didn't know what to do, cause like you do the opposite, so I didn't know.
You do the opposite of what's underneath here, there's nothing to do. So then you hop to this. So you're gonna take your y value and you're gonna multiply it by -1/2. So we don't have to do anything to the x value, because there's nothing underneath the radical. So all we're gonna do is take our y values and multiply them by -1/2. What do you get when you multiply? Let's do the 149. So that basically our x's are gonna stay the same.
0 for the 0 for the
Uh-huh.
first one, and then -1/2. Negative, and then negative.
-1.5, good. And then what are you gonna do here? Add 4, what do you get? Add 4 to these,
To the,
add 4.
4,
4,
3.5, 3, 2.5.
good job. Now, graph that.
isn't it
What do you think?
negative?
Huh?
Aren't they negative?
No, because you're adding 4 to the negative.
It's still gonna be negative, right?
No, because you're adding.
Oh, never mind, never mind, I wasn't that big, I was thinking of multiple.
Okay, so 0, 4, 1, 3.5, 4, 3, 2, 3, 4, and 9. I think this is 9, 2.5. Do you have it? Okay. And Jack's got it, graph, sorry. Here's his graph. It looks like what we have right here. Looks good. And let's verify our table. Control T. Are we right? 0, 4, 1, 3.5, 4, 3, 9, 2.5. Good job. Backside. Let me hear you. What do you do? Parent, what is it?
X minus 3. Oh, wait. No, I don't know.
Okay, what's the first thing you're gonna do? He said it. Andrew, go ahead.
X minus 3.
Take your x values and subtract 3. This is the first thing you do, what's underneath it. So we're gonna take our x values and subtract 3. What do you get?
-3.
Then what?
0, 1, 2, 3.
Okay, then what are you gonna do?
Y minus 2.
Well, first do this.
Oh.
B. Take your y values and multiply them by -1. Right? 'Cause there's a -1 there. What do you get when you multiply these by -1?
0, -1, -2,
Mm-hmm. And then what do you do?
-3. Y
What do you get? Subtract 2. Go ahead, graph that, and Jack's gonna type in the calculator for me. 1, 2, 3, 1, 2, 1, 2, 1, 2, 3. What's happening is it's being flipped over the x-axis. And here's the graph of it. And Jack's got it for us here. Looks good. Looks like what we have. Control T. And are other points right? Okay, let's see. Now, his calculator, it started at 0, but I need to look up. I wanna go up there, up there. -3, -2, that's good. -2, -3, 1, 4, and 6, 5. We're on a roll here. Next. Tell me what to do. What's the parent? 0, 1, 4, 9. 0, 1, 2, 3. Okay, first step. X plus 1. So what do you get when you add 1? And a lot of times I'll do that. I'll put my finger over the y so I look just at the x's.
So a
This is
So
your-
left is B.
Yep, A, then B, and
So
then C.
BAC, usually?
BAC, yes, yes, BAC.
1, 2, 5, 10.
Okay, what did you say?
So 1,
1, 2, 5, 10.
0, 1, 2, 3.
Okay, then what?
and then you multiply y by negative 2.
Okay, so let's do 1, 2, 5, 10. And we're gonna multiply the y values by negative 2. And then what? Take your y values and do what with them?
Plus 3.
So add 3, add 3, add 3, and add 3. Did you get 1, 3? 2, 1, 5, negative 1, and 10, negative 3. Okay, and looks like our graph is good, matched again. And Control T. Are we on? 1, 3 is good, 2, 1 is good, 5, negative 1, and 10, negative 3. And the last one. What do you do first? Parent function. Then what? Take your x values and subtract 4. Okay, then what? So that was our A operation. Now we're gonna times the y values by a half. So cut our y values in half. And then what?
Can you slow down for a second?
Yes, I will. I was going fast because I want to make sure you guys don't have homework. We'll get it done. So subtract 1.
Wait, how is 1/2?
Yeah, I was about to say, how'd you get, when you got 0, how'd you get 1?
Where?
0 times 1
Right
half.
here?
Or, oh, 2 times that half is, oh, never mind.
Yeah, you have this one? So, here we go. Jack did this for us, Control T, let's see if we were right. There was a little bit of confusion. We're looking for negative 4. Negative 4, negative 1, we're on. Negative 3, negative a half, we're on. 0, 0, we're good. And 5 a half. And we used our brains. How's that? All right, now,
Oh, no.
I told you that we were doing other radical equations. What's the difference between that, the ones we did and this one?
Cube.
You guys, this is easy. You guys did the hard part. What kind of numbers can you take the cube root of? Can I ask you, can you take the cube root of a negative number? Give me a number you can take the cube root of.
27.
Give me some easy ones.
Negative 27.
Negative 27. What is the cube root of negative 27?
Negative 3.
Good. What's the next number we know the cube root of? that you can do in your head, I don't want the decimal ones.
Eight.
-8, the cube root of -8 is
-2.
-2. How about the cube root of -1?
-1,
Cube root of 0,
0.
1, 8, and 27. Now, obviously, these are gonna be too big, right? So we're gonna concentrate on these. These ones are gonna be our parent function. So let's graph -8, -2. 1, 2, 3, 4, 5, 6, 7, 8. And Jack, I'm gonna have you graph. Get on the calculator. And if we connect our dots, it's not a straight line, but we said we had 27, -3, we had positive. So can we take the cube root of any number? Can we take the cube root of any number? Yeah, positive, negative. So our domain is all real numbers. What kind of answers do we get? All kinds, all real numbers. So our domain and our range is all real numbers. What would you say the shape of this is? What would you call this? Looks like a snake. Doesn't it? Now let's see if our numbers are right. What was the first one we got? Why does it do that? It locks. There you go. 8, there you go. There's 8, -8. Does anyone know why it does that? I know. Anyways, -8, -2, and if you scroll down, you'll see your other points. It like freezes on me. So now, memorize these. -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. What do you think you're gonna do now?
Hey, what did you put for the domain and range?
All real numbers. Because
For
you can
both?
take the cube root of any number.
For both?
Yep, for both. So, what was our parent function? What's our parent function?
Negative.
Let's just do -8, -1, 0, 1, and 8. That's the 5 points we're gonna use. So, what do you think you're gonna do with these 3 transformations? What's the first thing you're gonna do?
X plus 1.
You got it. You're gonna take your x value and you're gonna add 1. What x values am I talking about? These ones. So if you added 1 to all of these numbers, what do you get?
-7, 0, 1, 2.
And what do you do with the y values?
Keep them the same.
Leave them the same. Okay, anyone think they know what to do next? See how smart you guys are? You took your y values and you're gonna multiply them by 2. What y values am I talking about?
We're too
X plus
fast.
1
We're
y
too fast.
Okay, let's slow down.
And we got the.
You're gonna take your y values and multiply them by 2. Can someone tell me what they got?
-4, -2, 0, 2, 4.
No. The second one's 1, isn't it?
No.
Oh. What?
You're right.
Are we right?
Yeah.
Yeah.
Two times.
Alex, you're wrong.
I had 1 times school.
2, 2, 2, 2,
Mm-mm.
2. You're adding 1 to your
Oh,
x's.
No, the second one,
Yeah. -2.
That's good.
Be 2 times -1. You do it for what?
Okay, what's your third operation gonna be? Y what? Plus 3, yep. What do you get when you add 3 to these?
They never even make it.
Probably true. Probably true.
Okay, let's graph these.
Like I said, I would rather just like. Yeah.
Freshman home.
Okay, this is what I got. So my snake, it shifted, it moved over one, and it stretched, vertically stretched. Now, can we verify, Jack's typing it in the calculator for me. Does anyone not know how to type in cube root?
It's easy.
Anyone need me to show them that? So, here's the graph, it looks like ours, Control T. Let's see if our points are right. So, we have -7, -1. 0, 1, we're on. 1, 3, we're on. 2, 5, we're on, and bingo, perfect. Try another one. Number 3, what do I do? Start with what?
Parent,
What's the parent?
-8, -2, -1, -1, 0, 0, 1, 1, 8, 2.
Whoops, what did I do? -8, -0, 1.
X minus 4.
Okay, thank you, D'Angelo. You are taking your x values and you're doing -4. Can you tell me what you got?
-12, -5, -4, -3, and -4.
Is he right?
Probably.
Probably. What do you do with your y value?
9 times by -1.
Okay, well, these ones stay the same.
Do they just they become positive?
Now, this says -1, so we're gonna take our y values and multiply them by -1. So go ahead.
They're just positive.
Yes, well, they're opposite sign.
Yeah.
So this becomes a +2, +1, 0 doesn't change signs. Anyone know what to do next?
Y minus 2.
Y -2. Thank you, Travis. So if you subtract 2 from these y values, what do you get?
0, -1, -2, -3, -4.
Okay, so let's plot those points. -12, 0. I believe this is -12, 0. And we have -5, -1. And we have -4, -2. -3, -3. And 1, 2, 3, 4. It's, what happened to the snake? It shifted to the left and it flipped upside down. That's what it did. That negative in front does that. Let's check it, Control T. So, let's see, -12. -12, 0 is good. -5, -1 is good. -4, -2, -3, -3, and 4, 4.
Great deal, old man.
Okay, so what's your homework?
The last 3 problems.
The last 3 on your own. Can you guys do them?
I think you
You wanna do them together?
No.
No.
Okay, turn that off, thank you.